All right, on number 75, they ask us to sketch this curve, and you could do it with technology, but I also expect you to be able to do it without. So I'm going to do an example of without. And then it also asks for you to find the tangent lines at the pole. So we'll do that second. All right, as we graph this without technology, we want to evaluate the cosine at benchmark angles, the ones from the unit circle. So we're taking cosine of 3 theta, so if we set 3 theta equal to the benchmark angles, we'll know all the values of theta to try in our chart as we make a rough sketch. So this series of theta values will, when multiplied by 3, give us our benchmark angles of 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. And all these multiplied by 3 give us our benchmark angles. So we can now evaluate these without a calculator, multiplied by 4, and get our corresponding R values. All right, so this should be able to give us a fairly good idea of what's happening, and let's not go beyond this for now. When we plot all these points, here's what we get. Looks something like this. Comes through here like that. And we could keep going further, but we've demonstrated that we can generate ordered pairs that would give us the graph. If we go ahead and use technology to save ourselves the headache of doing more and more and more of this, here's what the picture ends up looking like. This part of the curve happened when we went from 0 through 1/3 of the pi. By the time we get to 2/3 of the pi, we'll have this. And then for the last third of pi, we will have that. Each petal will be congruent to the other ones. My drawing's a little weak, but you get the idea. And in this case, we could trace the entire rose picture with an interval of t values that went from 0 to 1 pi. All right, now let's come on over to this part. How can we find the tangent lines at the pole? The curve crosses the pole multiple times. There'll be multiple tangent lines. How do we find them? Well, at the pole, the radius must be 0. So 4 cosine of 3 theta must be 0 at the pole. On that interval from 0 to pi over 3, and then from pi over 3 to 2 pi over 3, and then from 2 pi over 3 to pi, we went here for pi over 3, then from pi over 3 to 2 pi over 3, went to here, and from 2 pi over 3 to 3 pi over 3, we went over to here. We crossed the pole 3 times, and if the R value is 0 at the pole, then this expression is 0, and 3 theta has to be when the cosine ratio is 0, which is at pi over 2, or 3 pi over 2, or 5 pi over 2. This goes on, but we know that we completed the entire curve after just pi, so we're not going to go to 6 pi over 2. All right, we have to divide by 3, and then we'll know our angle measures. All right, when theta is pi over 6, or pi over 2, and this divided by 3, 5 pi over 6. These will be the first 3 moments when the graph crosses the pole. Once at pi over 6, twice at pi over 2, and the third time when we're pointing in the direction of 5 pi over 6. All right, we know when the tangent lines occur. What are their equations? Well, we know that if a line goes to the pole, then its equation in slope-intercept form is mx plus b, where b is 0, so just y equals mx. So all we really need for the 3 equations of the 3 tangent lines at the pole are the slope. And we know that the slope is the tangent line, the tangent ratio of that angle. So tangent of pi over 6, pi over 2, and 5 pi over 6 is root 3 over 3, 1, and negative root 3 over 3, respectively. And those are the slopes of our lines which go through the origins, which have a vertical intercept of plus 0. There they are. These are the 3 equations of the tangent lines at the pole. I just noticed, though, in the textbook, if you look at the answer in the textbook for number 75, they interpret the question as where do these tangent lines at the pole happen, or when do they happen? So the answer in the textbook says these tangent lines at the pole happen when theta is pointing in this direction, or this direction. I interpret it as find the tangent lines, and actually went one step further and found those equations of the lines. On any cloud, I would be very clear about what was expected of you.